Hey, what's up, good people? I'm making this video to show how a computer works. Now, I've been meaning to make this video for a long time, for years, but you always get sidetracked and lazy and you never make it. But anyway, I'm making it right now. So one of my servers went down and I need to troubleshoot it. And this is a server that I keep a lot of, just extra data. It's got a big hard drive in it and stuff like that. It's an old computer somebody gave me. So this is I don't even know, it's a no-name brand. I don't even know the name brand of this computer. Somebody, like I said, somebody gave it to me, and because I can kind of fix computers, I said, I know I can make it work somehow. So it's a headless server, sits in a closet. I don't keep it plugged into a monitor. I run, I think I run CentOS 7, can't remember. I might have upgraded it to Alma Linux, but yeah, so it's not working. So it's basically a file server. So let's take a look at it and see. It'll boot up, but it just won't. I can't connect to it through SSH. So let's take a look. Put this down here so you guys can see. So take these off. And this I'm going to show you guys how almost every computer works, just about. Okay. So a computer basically takes about 4 main components. You got a motherboard, you got a hard drive, you got memory, and you got a processor. Okay, so even if you don't know what all that stuff is, I'm about to show you what all that stuff is. So if you look down here into the computer, hopefully you guys can see that. Down there is the motherboard, this kind of greenish thing that you see that's taking up the bulk. That's the motherboard. And a lot of components are plugged into the motherboard, okay? So let's see, the first component we have plugged into, the main component is, one of the main components, if not the main component, is the processor, the CPU. So the CPU is actually underneath this fan right here. You cannot see it. Let me go grab a CPU so you guys know what they look like. Hold on. Going to get a CPU. Let's see. I don't just keep CPUs just out, hanging out. All right, got a CPU. So I'm just showing you what a CPU looks like under that heatsink. So a CPU looks something like this. Okay, so CPU looks something like this. On the bottom is the part that makes contact with the motherboard. On the top, it's just smooth, and that's where the fan goes in the heatsink. Got to keep these cool because they get really, really hot. So that's CPU, Central Processing Unit. That's what that stands for. CPU is Central Processing Unit. This would be a good time for you guys to make notes. So you have a CPU. You also have memory. So let me show you what the memory looks like. Memory looks like this. Now, some of you guys that are watching this channel that are already computer experienced, you're like, hey, why is he showing them memory? Like, that's not too high-tech advanced. Well, a lot of people today getting into cloud, getting into computing, they don't even know what memory looks like, to be honest with you, because they've never had to physically open up a computer. It's almost like somebody that doesn't know what a DVD is, or a VHS cassette tape is, or a laser disc is. If all you've had was Netflix, you don't even really know what those things look like. There's people that don't even know what a CD looks like. I mean, a lot of people do, but a lot of people don't. They don't know what a vinyl record, a cassette tape, or 8-track looks like because they just deal with cloud services like Spotify. So they don't know what the physical medium that actually holds the data, they don't know what it looks like. So this is a memory stick. This computer, this is an 8 gigabyte memory stick. This computer can take up to 16 gigabytes total. So I've got 2 8 gigabyte sticks in here. So you got a processor, Central Processing Unit. You've got memory. You've got the motherboard. And then you also have something called a hard drive. So let's see what a hard drive looks like. Let me take this out. Let's take the hard drive out. So the hard drive is where you store your data, okay? Your data at rest. When the computer is off, everything is stored on the hard drive. So you keep it on there so you don't lose anything. And I'm gonna take this out. And this is what a hard drive looks like. This is what we call a SATA hard drive, SATA, serial asynchronous transfer something. It's called SATA because of these connectors, the type of connectors it takes. Okay, now I told you that I was going to tell you how a computer works, and I'm going to do that right now. So when you first buy a computer, it has an operating system on it. Okay, what is operating system, you're asking? The operating system is software. What is software, you're asking? Software is computer code. It's computer code that is stored on a hard drive. Okay, you don't really see it. It's code. So if you need any more deeper description than that, you might have to Google or ask ChatGPT. But it is software that's stored on the hard drive. So I'm going to give you a hypothetical scenario. You buy a new computer. It has Windows. God forbid it has Windows. No, let me stop. It has Windows, or it has Linux, or it has Mac OS stored on the hard drive, okay? When you first turn the computer on and boot it up, part of the operating system gets copied off of the hard drive into the memory stick that I just showed you. Just not the whole operating system, just part of it. Enough of it that you can display something to the computer screen right here. So let's say 2 or 3 gigabytes of information gets copied off of here, because this is big. This could be a terabyte. This could be 500 gigabytes. Memory is normally much smaller as compared to hard drive space. So part of your operating system gets copied off into memory. Why does this happen? Hard drives are slow. Memory is much faster. And the CPU is like the fastest thing on the computer, okay? So it gets copied into memory so that it can get displayed on your computer screen, and you can interact with the operating system, with the Windows desktop, with the Mac OS desktop, okay? Now, you may have some, your computer may have some applications that came with the computer. I'm just gonna give an example, Photoshop. Photoshop doesn't come with any computer that I know of, but I'm just saying, like Photoshop or Word or Excel or something, some program you use came with the computer. When you make a Photoshop file or a Word file or an Excel file, those files, you normally hit save and you save them. You save them you get saved to the hard drive, okay? Nowadays they have autosave. You don't even have to think about it. It gets saved to the hard drive. So, okay, let me back up a little bit. You have a program, pull this up some. You have a program like Photoshop. You're working on some images or a Word document. You open up the application. You click on the little icon. It bounces up and down or whatever, and it opens up Word. You're working in Word, you're creating your document, you're hitting save, or it's auto-saving. It's getting written to the hard drive every time it saves. Whether it auto-saves or you manually save, it gets written to the hard drive. If you don't save it and you close out that program while you're still working on the document and it's not saved, it's just in memory. When you close out the program, the information that you've been working on is gone. So you have to save it to the hard drive, so it'll be there the next time you boot up your computer. Furthermore, one thing I didn't clarify is that when you clicked on the little icon or the little picture to open up Word or Photoshop or GIMP or DaVinci Resolve or whatever you're using, when you open up the program, part of that program got copied into memory, again, so you can interact with it with the computer screen. So memory is very important, because memory is where you're holding all the active data that you're working on, okay? It gets stored into memory, those memory chips. But let's just show you guys again, in case some of you missed it. It gets stored into memory while you're working on it. It gets pulled off the hard drive, stored into memory. Then you're working on it in memory. When you do something or add some processing, like some effects in your video editing or your photo editing or whatever, it goes through the processor. Actually, a lot of actions are moving through the processor, but I'm just oversimplifying this just so the greater public can understand how a computer generally works, okay? It's very general, but it's good enough. So memory, storage, block storage for some of you cloud people, EBS, this is a block storage. This is memory. And then you also have your processor, okay? And everything plugs into the motherboard. So what do we learn? We learned that you turn a computer on, the operating system gets pulled off the hard drive, part of the operating system loaded into memory. We also learned every time you open up a program like Photoshop, Word, or whatever, a little bit of that gets pulled into memory too, so that you can interact with the program. We also learned that you need to save what you're working on to the hard drive so that it'll be there when the computer wakes up. We also learned, well, we might didn't learn, but I'm telling you now, the more memory you have, the better. It's good to have a lot of hard drive space so you have a place to store stuff, but memory has to do with, like, think about how many tabs you can have open or how many windows you can have open on your desktop. More memory you have, the more that you can do. We didn't talk about GPUs and all that kind of stuff and graphics because this is just general. You just need to know when you go buy a computer, you need to know how big the hard drive is, how big of a place you have to store all your junk. You need to know how much memory you have because you need to know how much space you have to work on your junk when it's open. And the processor, you want to know how fast that is because you want to know how snappy the computer will be. In all fairness, the hard drive, the memory, the processor all have to do with the snappiness and the speed of the computer a little bit, but those general components do what they do. Storage is for storing long-term data, memory is for working with active files and things, processor is for processing what you've worked on. And so that's about it. The only other thing I can tell you, this is a 3.5 hard drive. It's big, it's kind of fat. They call this 3.5. And they make another size hard drive. I'll show you guys. This is I've got it in a chassis here, but this is a smaller hard drive. It's like a laptop hard drive. Don't worry about this casing that it's in, but just look at this little wafer, right? This is a hard drive. So this compared to this. So you got and this is a solid state hard drive, used mainly in laptops. And actually even today, I was gonna show you an example of an NVMe. There's even a smaller hard drive that looks like memory. Hold on one second, let me show you one more thing. Where's my, I don't know where I had an NVMe drive. Show you guys an example. And I don't know where it is. I don't know where it is. But suffice it to say, it looks like a memory. It looks like a memory stick. Where's it at? I'm gonna find it. I shall not be defeated. I shall not be defeated. I got this Bluetooth microphone on me, so I'm even curious if it's working while I'm in a completely another room looking for this NVMe drive. I'm not gonna cry about it, but I promise you guys, I had that drive. Oof. Boggles my mind when now wait a minute, as my granddad would say. No, wait a minute. I know I had that thing. No, wait a minute. All right, well, damn. And what ticks me off is I know I'm gonna find it as soon as I stop this video. That's what's annoying. Let me look one more time. One more time. Told y'all I wasn't gonna be defeated. So let me show you the third type of hard drive, which is NVMe. And it's important to kind of know this because if you start working in cloud storage, you'll hear people refer to NVMe drives. So an NVMe drive looks like this. Kind of looks like memory. So you got NVMe, the smallest. You got 2.5 SATA drive. And then you got the biggest, the 3.5. Okay, so that's your different hard drives. And also, one more thing for you cloud people is there's an interface called SATA and there's an interface called IDE. And you're probably thinking, okay, what does that mean, Elliot? Well, again, that has to do with the connector. That is IDE. That is SATA connector. Let me show you what IDE looks like. I don't have an IDE hard drive, but I do have this little memory board that I took out of an old IDE hard drive. And this is what, there's the power and there's the actual where you plug the IDE cable into it. And as you can see, this is different as far as two different kind of connect. This came off of another hard drive, an older type hard drive that took IDE. So it was there, but I took it off, I unscrewed it because that hard drive went bad. All right, that's it. That's how a computer works. If you have any questions, just email me and ask. Peace.